Hi there, and welcome to Mr. Morgan's Math Help. This is Algebra 1, Unit 4, Lesson 3, called Solving Equations Literally. Alrighty, so today, learning focus is comparing strategies for solving linear equations and literal equations. So linear equations and literal equations. So how is solving an equation with one variable similar to the work of solving an equation with more than one variable? So we're just, again, solving equations sometimes with one and sometimes with more than one variable and looking and comparing how are those things similar. So you began today's lesson with some work with solving equations for x, which required you to take a problem like this and work through it to figure out how to get x by itself. And so, for example, in the first one, you might have had 3x plus 2 over 5 equals 7. And so to get that by itself over there, a couple things we're going to be doing here, and this is what comes up really in the second part of your lesson, is we're going to be doing talking about some reasons why. So we're going to multiply both sides by 5. Okay, now this is referred to as the multiplication property of equality. Okay, so by doing that, then when I multiply that together, I have 5 multiplied by both sides, and so that's what's happening there. And so then if I was to really break this apart, this becomes really 5 over 5, or 5 times 1 over 5 here, times 3x plus 2 there, equals 7 times 5 there. Now, what I'm showing you here with this part, which is multiplied by 5, is that 5 is really 1 over 5. And so this is actually what we would refer to as the associative property of multiplication. We're showing you how those things kind of work together. Now, when I do what's called when I reduce this next, this becomes really 1 times 3x plus 2 equals 7 times 5. Give it that. So that is the multiplicative. This is called the multiplicative inverse property. That's how you get the 1 there. And then once that's done, then you end up with 3x plus 2 equals 7 times 5. So that becomes your multiplicative identity property. Identity because it's 1 times the number there. Okay? And so that's kind of what we're doing so far. And then you end up multiplying this together to get 35, 3x plus 2, but we're not done yet. So we end up having to subtract 2 from both sides. Well, when I subtract 2 from both sides, what am I doing? I'm now using the subtraction property of equality to end up with 3x equals 33. And then I'm not done yet. I end up dividing both sides by 3, so that x equals 33 divided by 3 is 11. And now at this point, I'm using the division property of equality to then get down to this point here. So in one problem, what I'm trying to show you here in a really annoying way is that to solve this problem, we use the multiplication property of equality. We use some associative property to move things around. We use some subtraction property equality and division property equality in order to move from this equation all the way down to a solution of x equals 11. That's part of what you did in your second part of your lesson today. I just want to write it out real quick for that one because that's the idea of part of the lesson today. Okay, for how these things work. And so your teacher hopefully gave you a whole bunch of terms that you can use later on for describing things. So let's take a look at some other ones here. Number 2, if you wanted to solve for x here, I'd multiply both sides by 5 again. So you end up with 3x plus 2y equals 35. I'd subtract both sides, 2y from both sides, so I end up with 3x equals 35 minus 2y. And then I'm going to divide everything by 3 so that x equals 35 minus 2y divided by 3. So it's a little bit uglier, so to speak, but it does definitely work. It just doesn't maybe come out as pretty like x equals 11, but that's all right. That's how it works sometimes. When we look at the next one here, we have 4x divided by 3 minus 5. First thing I would do is add 5 to both sides. So I'm left with 4x divided by 3 equals 16. Now I'm going to multiply both sides by 3 using the multiplication property of equality. And so that reduces down to 4x equals 16 times 3, which is going to be 48. We'll divide both sides by 4 using the division property of equality so that x equals, in our case here, 12. Okay, so again, using these terms as we're going along, because that's what this part of this lesson is about here. For number 4, right, same idea. We're going to go ahead and, first of all, I'm going to write over here, so some space. So 4x divided by 3 minus 5y equals 11. I'm going to add 5y to both sides. So that I have 4x over 3 equals now, I could write 5y plus 11, or 11 plus 5y. Now I'm going to multiply both sides, the whole thing, by 3 to end up with 4x equals 3 times 5y plus 11. And then I can divide everything by 4 so that x equals 3 times 5y plus 11 divided by 4. And that's what I'm going to leave it as for now. That works just fine. This next one, we have 2/5 times x plus 3 equals 6. So I'm going to multiply by the reciprocal, in this case here. And so I end up with x plus 3 equals 30 over 2. And 30 over 2 is the same as, I guess, kind of wrap that up, is equal to 15. Then I subtract 3 from both sides. So x is equal to 12. And then for our last one here, we have 2/5 times x plus y equals 6. So we multiply both sides by the reciprocal, 5 over 2. So we have x plus y equals 30 over 2, which we already know is 15. We subtract y from both sides so that x equals 15 minus y. Number 7. 2 times 3x plus 4 equals 4x plus 12. All right. Now on this one here, a couple different approaches here. What I would do is, depends on how I'm feeling. I'm going to go ahead and use the distributive property to distribute that 2 through this part of the equation. So I'm going to do 2 times 3x is 6x. Plus 2 times 4 is 8, and I'll make that equal then to 4x plus 12. I'm going to do that just so I can manipulate my variables a little bit. I'm going to now subtract 8 from this side. So 6x equals 4x plus 4. I'll subtract 4x from this side. So now 2x equals 4. Now I'll divide both sides by 2 so that x equals 4 divided by 2, or simply 2. Other ways you could have done it, I could have divided both sides by 2 to begin with, and that could work as well. So you could have done 2 times 3x plus 4 equals 4x plus 12. I could have divided the whole thing by 2, and that would have left me with this side as being 3x plus 4. And then by dividing this, I do 4 divided by 2 is 2x, and then 12 divided by 2 is 6, so I end up with 6. And now when I subtract, I have x here, subtract here, equals 2 there. So you end up at the same place, just a different way of going about it. All right. Number 8, same idea. You can distribute, and then solve that there and get towards a solution for that one. That one you should end up with something like x equals 2y once you solve number 8 for that work today. So the lesson here really is looking at different strategies for solving linear equations. So some practice there, and literal equations, and talking about the different processes for solving them, as well as the different types of properties that you're using to solve those things. So the multiplication property, associative property, multiplication inverse, those types of things. So see what your teacher wants you to kind of have in your knowledge bank so that you can answer those things properly when it comes up there. There's also things like the squaring property of equality. We did the addition one, so that's kind of the idea. All right, so I'm going to pause there, let you start to work on your homework a little bit tonight, and then come back in here so that we can talk about these things together in just a minute. See you in a minute. All right, here we go. Let's take a look at homework. Hopefully you have done your best and you're using the video to check your understanding, not to get your answers. Come on. And for my lovely friends who like to post, the answer started 13.4. Like, yeah, great, good job. Just do your homework. Okay, perform each operation described in the first column on the table inequality, and then record the work in the second column and state whether it is true. All right, so what we're going to do for these guys here is, it says subtract 7 from both sides. So what we're doing is we're saying, all right, we have a negative 9 minus 7 is less than 2 minus 7. When I kind of work this out, that becomes negative 9 minus 7 is a negative 16. Less than 2 minus 7 is negative 5. Is that still true? Yep, it's still true. So that's what we're doing this whole time. Okay? So for the next one, we take our negative 9, and it wants us to add 15. So we add 15 to it. And then we do our 2 and add 15 to it. So negative 9 plus 15 is going to be a positive 6. And 2 plus 15 is 17. Is 6 still less than 17? Yes, it is. So that is true. Number 10, add a negative 10 to both sides. Sure, so negative 9 minus 10 less than 2 minus 10. This becomes a negative 19, and this becomes a negative 8. So negative 8 is still greater than negative 19. That's still true. Let's multiply it by 10. So negative 9 times 10 less than 2 times 10. Let's see if it works. We have negative 90 less than 20. That is true. Divide, okay, so negative 9 divided by 5 less than 2 divided by 5. Well, is that true? Well, a negative is definitely less than a positive, so that's going to be true. Let's multiply by negative 6. All right, sure. Negative 9 times negative 6 less than 2 times negative 6. All right, so negative 9 times negative 6 is going to be a positive 54. And 2 times negative 6 is negative 12. Oh, I think we have a problem here, don't we? 54 is not less than negative 12. So that is not going to be true. That's a false statement right there, right? And the reason that's false is that when we multiply by a negative number, we have to change our sign around. It should be 54 is greater than negative 12. That's going to be a problem if we don't remember that rule. Next, divide both sides by negative 3. So negative 9 divided by negative 3 is less than 2 divided by negative 3. So that really becomes a positive 9 over 3, or a positive 3, is less than a negative 2/3. So a whole number 3 being less than a negative number, that's false as well. This should be what? It should be 9 over 3, or 3, is greater than negative 2/3. That's what it should be. So I have a problem when I'm multiplying or dividing by a negative number, don't I? Which is really kind of your next question. So when multiplying and dividing by a negative number, I need to make sure that I reverse the inequality whenever I multiply or divide by a negative number. So make sure you do that when you're working with inequalities. Number 3, And 4 and 5 and 6 and 7, it says to solve for the indicated variable and show your work. These are ones I believe you should be able to do pretty well, right? I'm going to go ahead and do number 5 real quick. These ones are straightforward. So I'm going to multiply both sides by 7 to have x plus 2 equals 28. And subtract 2 from both sides, so that x equals 26. That's all they're wanting you to do is just solve it like that. Okay? Now, if they have ones with multiple variables in them, which they do for some of these ones here, I guess I probably should do another one here. 6, yeah, I'll do one. Let's do 6. We're going to keep that variable like it is. So let's multiply both sides by 7. So x plus 2y equals 28. I still want to get the x by itself, so I'll subtract 2y from both sides. So x equals, in this case, 28 minus 2y. So we leave it with the two variables there. Number 7, looking at that one, same idea. First move your whole number over there using the addition property, right? And then we're going to get rid of the 5, and then you end up with a 2x, and you could probably get rid of the 2 as well. So we have first step here, second step there, and the third step is there. So 3 steps for number 7. Number 8, same idea, except now, if we look at it, we're going to move this guy over, right? But keep the y. And then we'll worry about multiplying that out. That's step 2. And then step 3 will be to divide that by everything. Okay. And number 9, same kind of idea. Multiply both sides by the reciprocal, first of all. So you have x minus 2 equals, and I can divide this first, equals 16. I can add 2 to both sides. So x equals 18. And in a similar way, solving for this one, multiply both sides by the reciprocal. So x minus 2y equals 16. And now I have 16 plus 2y because I add 2y to both sides. Okay? All right. The next few, we have to locate the x and y intercept in the table and write each one as an ordered pair. So the x-intercept and the y-intercept, just as a remembrance here, I have a couple points. I have x is at 0, 4. 1, 2, 3, 4. So there's a point there, 0, 4. And that one's crossing the what? The y-axis there. And I have this one here at 2, 0. And that's crossing the x-axis, right? So what does that mean? When x is 0, we're talking about the y-intercept. When y is 0, we're talking about the x-intercept. Okay, so in this case here, our x-intercept is going to be when y is 0. So we're going to be at 2, 0. And our y-intercept is when x is 0, so 0, 4. You don't have to graph it or anything. I mean, you certainly could, but you don't have to graph it. They just want you to look at the table and figure out where's your x and where's your y-intercept looking at that table. All right, the next one, we have our x is 0, our y is 0, right? So if you were to graph that, when x is 0, y is at -6, somewhere down here, 3, 4, 5, 6. And when x is at 18, right, it's over here. So your x-intercept, in this case, is going to be at 18, 0. That's your x1. And your y-intercept is at 0, -6, right there. Okay. All right, and your next one's, again, same idea. You can see the table. You should be able to find your x and your y for 13. For this one here, there's not a table, but instead they give you a graph. And so, again, it should be even easier, right? We've got to look at our numbers here. We have 5, 6, 7, 8, 9. We have a point right there. We also have a point right there. So those are your points, and you can see which one is your y-intercept and which one is your x-intercept. So make sure you write those as an ordered pair, right? X comma y, and then list those down there. Number 15, same idea, right? Here's our y, here's our x, and we can see that we have a point right there, and a point right there. So then label those as they should be. We have our y-intercept, and we have our x-intercept. All right, number 16, 17, or 16 to 22. What we're going to be doing here, this is the part, back to our lesson a little bit here, is they want you to not just solve each equation, but provide what's called a justification for each step. So just reminds you types of justification: addition property of equality, division property. There's also going to be the subtraction property of equality, and we're also going to have the multiplication, perhaps. And I think those are the only ones you have to use today. So these 4 terms, they want you to essentially list as you're solving each step. So for example, on the first one, if I have 4x minus 10 equals 2, the first thing I would do is add 10 to both sides. Now when I'm doing that, what am I doing? I'm using the addition property of equality right there on that line. So then I do that, and I have 4x equals 12. Now I want to get the x by itself, so I divide both sides by 4. When I'm doing that, what am I doing? I'm using the division property of equality to have x equals 3. So I solved it, is one thing they want me to see, but then I'm also showing which property I'm using along the way in order to get to that solution. So those are all the parts that your teacher's going to want to see for how this works. Now they wrote a little note here, justification, just so you knew what was happening here below that. This will come up later when you're having to do or create what are called proofs. Not my favorite thing, but it's part of what we're building towards. All right, so number 17. Same idea, right? You're going to do one step at a time. And so maybe I want to subtract 11. And doing subtraction, what am I doing? I'm using the subtraction property of equality. So I end up with a negative 27 here equals 3x. I want to get the x by itself, so I'll divide both sides by 3. So I'm using the division property of equality in this step, and I have 27 divided by 3. Well, what's that about? I have no idea. Negative 9 equals x, and that becomes my answer. So I have both my solution and my justification there. All right, same thing for 18. Do the same step for 18. And 19 and 20, nothing really too fancy there, right? We're just moving things around. And 21, 22. 21, same idea. Let's look at 22 together. That one's a little bit different. It depends on how you look at it, right? If I want to get x by itself, I guess I don't have to work too hard. I just want x by itself. So I would just divide both sides by b plus 7. In my head, I was doing more than I needed to do. So this is going to be the division property of equality there. So x equals 9 over b plus 7. That's all we have to do. So we leave it like that, and that's our solution. All right, and that really is it for the day. Hope that helps you out a little bit, and we look forward to seeing you here next time.